All right. Welcome. There we go. Okay, so I have this clock here on the side, just to remind me how much time I have. I don't know where to put it. Maybe down right here. Anyway, it should make a sound when we are out of time. I just don't want to go over the lesson, and this is, I don't imagine that I will. We don't really ever teach for an hour and 14 minutes. But this is Unit 9, which is the analytic part of trigonometry. This is the part of trigonometry where we are going to focus on the solving and the equations, areas, stuff like that. The next half of trig that you will do in Unit 10 is the graphing part of trig, which is kind of fun. So let's begin. This first image is the unit circle. We will talk more about that next time. But just as kind of a very brief overview, don't write anything down. But as a very brief overview, this right here, maybe I'll just highlight it. This right here, and this right here is the XY axis. So as different angles turn around the axis, I can correspond those angles with different XY points. And this unit circle looks intimidating. There is a pattern to it, as there almost always is in math. The math is full of patterns. So there's a pattern to it that's going to make it much easier to do. However, we don't have to worry about that today. On the test, you will not get the unit circle, and so you have to have all of these little pieces memorized. I shouldn't tell you that on the recording. Pretend like I didn't say that. You have to have all of these pieces memorized for the test. And I'll show you the pattern next time to make it easier. You also will have a quiz on this coming up in the next few days. But let's not worry about that for now. Is that buggered? Alright, so this is a full trig review. In fact, you've already had, if not this exact lesson, you've had something just like it at the beginning of the school year. We're going to do it one more time, however, just to get your mind back into the trig mode. So all trig is, trigonometry, all it is a ratio between the two sides of a right triangle. In today's lesson, they will really focus on three things. The three things are you need to be able to identify trig ratios. You need to be able to find missing sides using trig. And you have to be able to find missing angles. These two right here, my students normally have no problem on. This right here is the easiest. But for some reason, whenever I ask you to find a trig ratio, by the way, what's a ratio? A ratio is just a fraction. It's taking one side and putting it over the other. Whenever I ask you to find a trig ratio, for some reason you think that I'm asking you to find this and this. So there's kind of an error alert. I am not asking, anyway, let's move on. I'm not asking for missing sides when I'm asking for a ratio. I'm literally asking for one number over the other number. One number over the other number. Okay, so come back. Unit 9. Whew, there are 13 units if we get to all of them. So if we are on 9, we are almost there. Okay, so there's one word that should help remind you of what sine, cosine, tangent is, and that word is, did you say it out loud? Because you should have said it out loud. That word is SOHCAHTOA. Sine is the ratio of opposite over hypotenuse. So based on, every single time they're going to give you an angle, and based on that angle, imagine yourself standing here at the very tip of it. There is going to be an opposite side, so you would walk through the triangle to get to the opposite side. There is going to be a side across from the 90, which is called the hypotenuse. And then the last remaining side, the adjacent side, would be to the other side of the hypotenuse. So if you were standing right here, on one side you have the hypotenuse, on the other side is your adjacent. Cosine stands for adjacent over hypotenuse, and tangent stands for opposite over adjacent. So notice the 19 stars that we put right here and right here to remind you. Trig ratios are functions that take an angle as an input and give you a ratio. Angle in, ratio out. Inverse trig functions do the opposite, taking a ratio as an input and giving you an angle, ratio in, angle out. And I'll explain that more in just a minute. Kind of a confusing way to say it, but maybe we'll look back at it in a second. So for example 1, I want you to find each trig ratio. So I'm looking for the cosine of theta. This is theta. So the very first thing you do is mark your angle, then you're going to label your sides. Based on this angle, this is my opposite, which I don't care about because there's nothing there. This is the hypotenuse. So this has to be the adjacent. Cosine is A over H, so 15 over 17. Part B, I'm looking for the sine. On this one, this is my angle. You walk across, this is the opposite. This is the hypotenuse. Sine is O over H. However, on this particular problem, you don't have the H. So you need to remember one other thing on how to get the H. How would you? We need to apply the Pythagorean theorem, which says a squared plus b squared equals c squared. So 6 squared plus 12 squared equals x squared. 36 plus 144 equals x squared. 180 equals x squared. And take the square root. Off to the side, I don't want this as a decimal. I need that number as a square root still. So let's come off to the side and see what the square root of 180 is. Jump over here to the blue. 180 is 18 times 10. 18 is 9 and 2. 10 is 2 and 5. So I have my first group right there. And 9 is 3 and 3. I have my next group right here. So the 2 and the 3 combine to make a 6. The 5 is my loner, square root 5. So I could rewrite this as x, still struggling, hold on. X equals 6 square root 5. So this length right here is 6 square root 5. That's a rude problem. Okay, so when I write O over H, let's write it. Opposite is 6. Over 6 square root 5. I think I'm going to make this so you can see it a little bit better. Okay. Now there's a couple things that can happen here. I noticed first that the 6's will cancel. One's on top, one's on bottom, so I can rewrite it as 1 over the square root 5. And a long time ago, there was a decision that was made that says we cannot have the square root in the denominator, so we have to do what's called rationalizing the denominator. So let's take the top number and the bottom number. We have to get rid of the square root 5. So if you recall, this is how you do it. On top, we had this lesson, so you better remember that this is how you do it. On the top, you have the square root 5. On the bottom, you have 5. So this right here is the sine ratio. So on your own, find the cosine ratio. Go ahead and pause it for just 1 second. Oh, that's not going to work. No, pause it. Keep going. I need to watch the time. So on your own, try to find part C. I will give you 1 minute. Okay, so we start by labeling the sides OAH based on this angle. This is my opposite, this is my hypotenuse, and this is my adjacent. Cosine is adjacent over hypotenuse. So I have the adjacent, I just need the hypotenuse. So if I use the Pythagorean theorem, a squared plus b squared equals c squared. 9 plus 16 equals 25. Equals x squared. Take the square root. So this length would be 5, which is nice because anytime the hypotenuse is a square root, we're going to have to rationalize the denominator. So in this case, 4 over 5 would be my ratio. All right, keep going. What about this problem? Find the cosine if the tangent is 3/4. Any ideas on how you would go about this problem? So for this one, it's a lot easier to do if I have a picture. Now, this right here will guide my picture. This is my angle. I'm going to mark one of them as theta. The picture might be off a little bit, so you can't judge it according to scale, but if the tangent is what over what? It's SOHCAHTOA. So tangent is O over A. So based on this angle, my opposite is 3, right? My adjacent is 4. And we just did the Pythagorean theorem on this one on part C, right? It was a 3, 4, 5 triangle. This is a Pythagorean triple. I've seen the Pythagorean triple on ACT questions before. So a Pythagorean triple, they are 3 numbers that form a right triangle. And I know it forms a right triangle if you plug in a squared plus b squared equals c squared. If those numbers work for you, then I know it's a right triangle. So 3, 4, 5, 6, 8, 10, any multiple of 3, 4, 5 is a Pythagorean triple. And there's infinitely many Pythagorean triples, unique Pythagorean triples. So I can't list them all for you, but if a squared plus b squared equals c squared, then it's a Pythagorean triple. Okay, so I know this is 5 because I did the Pythagorean theorem over here. And then if I'm trying to find cosine, based on that angle, cosine is adjacent over hypotenuse. So the cosine of theta is 4/5. Okay, Last one, part E, find the sine of theta if the cosine is 8 over 17. I believe this will give you another Pythagorean triple. So take 30 seconds this time, see how far you can get. And y'all better be trying because it's very awkward to sit alone in my classroom on the night of sweethearts, doing math, watching the counter go down. So 30 seconds, try it. Okay, we need a reference picture. So let's go there first. Oh, pretend like that looks like a right triangle. You pick any angle you want to be theta, it doesn't matter. I need to find the sine, but I know the cosine. Cosine is A over H. So A over H. Now I have to do the Pythagorean theorem on this one because I don't know that last side. This is going to end up being a Pythagorean triple. So whatever this side is, set it up. So x squared plus 8 squared equals 17 squared. X squared plus 64 equals 289. Subtract the 64. So x squared equals 225. Take the square root, x equals 15. So this length right here is 15. And if I want to find the sine, which is OH, I'm going to say the sine of theta equals 15 over 17. I'm pretty sure I just looked at this test. I could be wrong. I don't remember if I looked at the test or the review, but I remember seeing that on there. So you have to be able to do those. I'm going to give you just, I don't know how to do this. It's so hard, guys, with me not being there. Take 30 seconds and clarify anything with anybody around you. If you have a substitute that can help, then feel free to ask questions. You can pause it if you need to take more questions. So help each other out. I'm hoping this is a review, and then let's move on. Okay, so again, 3 parts of today's lesson. The first part was be able to identify the ratio. Again, the ratio is only the fraction. Can you do that? Mentally give yourself a 5, 4, 3, 2, 1. How well do you understand that? 5, let's move on. I remember it. 1, I need to talk to the person sitting next to me, behind me, in front of me. Now let's go on to the second one where we have to find the missing sides and the missing angles. Now, because this is a review for you, it is melded all into one section. So for part A, let me get this a little bit higher on my board. Okay, you know what you're looking for based on the variable. For part A, I have the variable being the theta, which means I need to find a missing angle. For part B, I have the variable being a side, which means I need to find a missing side. It is easier to find a missing side. It takes less to remember. So let's start on part B. Start on part B, and then we'll go back to A. Maybe B and then C and then A. I don't know. Okay, so the very first thing you do, if I were to give you steps, the steps are the same regardless. First step is to mark the angle and label sides. So on part B, in this case, we are given the angle theta, angle 29. So that's what I'll use. On part A, we would use theta. Now, based on this angle that you know is 29, across from the 90 is the hypotenuse. Next door to the 29 is the adjacent side. So this comes to step 2. We have to decide SOHCAHTOA. Which one of sine, cosine, tangent am I using? Which one uses the A and H? In this case, it's a cosine. So that moves us on to step 3. We have to write the trig ratio using the cosine that we found for step 2. So the cosine, sine, tangent, trig is always based on angle. So the cosine of angle 29 equals adjacent over hypotenuse, which leads us to step 4. We can write it really small right here. You have to solve. So we have to solve using whatever solving methods we know. Now, these are ratios. I don't know if it's easiest to put it into a proportion and solve it that way. So how do you solve a proportion? You cross multiply. So x times cosine of 29 is x times the cosine of 29 equals 9 times 1. And then the x and the cosine are connected by a multiply. So you have to cancel the multiply, which would be divide. So let's divide by the cosine of 29. So your missing side x equals, my battery's going to die. Oh, yep, there it is. No, not yet. 9 divided by the cosine of 29. Pause really quick. I don't have, somehow I lost my graphing calculator on my computer. Give me 1 second, maybe I can show you. Give me 1 second. What I am doing right now is hooking up my data projector so I can show you my calculator, because we need to make sure everybody is on degree mode. You should be, because that's what we've done all year. Wait, have we even done Trig? I don't even know if we've done Trig yet this year. So maybe you aren't. But if you're in radian mode, which we will discuss radians here in a bit, it's coming up. If you're on radian mode, the calculator is not going to give you the right answer. All right, so hopefully, in just a second you can see this. Here's my pretty favorite calculator. There we go. So right now I've typed in the cosine of 29, but I need to confirm that I'm in radian or degree mode and not radian. So on the Casio, you do it a little bit different, and if we have time at the end, I can show you. But on the, well, hopefully you can figure it out. But on the TI, there's a mode right here you're gonna pick, and you can't see that. Hold on. Maybe. There we go. Gotta darken it up. So right now, see how there's a couple options down that says radian degree? I need to make sure I'm in degree mode. Ooh, dark. So when I click on degree mode, then I can quit. So second mode is quit, push enter. And 10.3, 10.29 is the missing side. So let's go back and put that in. Alright, x equals 10.29. Why don't we just plan on rounding to the hundredths place? So let's do that again. Sorry if that took forever and you're like, we get it, move on. Part C. Based on my 54-degree angle, I have an opposite and I have an adjacent. So which of the three SOHCAHTOA do I use here? Tangent, TOA, OA. Tangent of 54 equals opposite over adjacent. So again, we need to solve this. X is in the bottom. Let's write a proportion. X times the tangent of 54 is x times the tangent of 54 equals 2 times 1, which is 2. Then we have to cancel this divide right here, so let's divide by the tangent of 54. Those cancel, and x equals, grab my calculator, x equals 1.45. Now it would be worth your time to compare your answer to the other numbers that are around your triangle. For example, 1.45 seems kind of small, and then I looked at it, this one was a 2, so I mean they're in the same neighborhood. It makes sense that this answer could happen. On part B, 10.29, roughly 9. It is possible for one of them to be 10 and one of them to be 50, but it's not likely. And if you have one of them being 10 and one of them being 200, then I would say you're definitely far off. Also, making sure your answer makes sense in context of the problem. I had a student last year, bless her sweet hide, did her entire test in radians. Now radians can be negative, and so when you're typing this in radians, she had all of these answers that ended up being negative. So a negative angle or a negative sign, and the answers didn't make sense in context to the problem, but she didn't even take a second to check that. She just said that the angle was negative 2 degrees, or the side was negative 3 feet, which made no sense. So make sure you're checking your answers, see if they make sense in context of the problem. Okay, now let's practice finding a missing angle. So for this angle, we do it the same way we did before. Mark the angle and label the side. So based on angle theta, this is opposite. This is hypotenuse. Step 2 is the same. Decide, am I using SOHCAHTOA? So OH would be sine. But here's the major difference. I'm not doing the sign of a number. I'm doing sign of the variable. This is what I'm trying to solve for. That is what I'm trying to solve for. Okay? So sine theta equals opposite over hypotenuse. Sine will always be less than 1 because it's always the hypotenuse on the bottom. And you can, when you divide it, it's always going to be less than 1 because this is the biggest number, always. Now you have to remember what the inverse of sine is. Remember, multiply has an inverse, it's divide. Squaring has an inverse, it's the square root. Exponential has an inverse, it's the logarithm, which is what we did last unit. The inverse of sine is called the arc sine. And there's 2 ways to write it. You could say arc sine, or you could say sine with that little -1. Remember when we were doing inverse functions and we used that -1 to note that it was an inverse? Now the sine inverse and the sine will cancel because this is the sine of theta. They are 1. I can't just divide by sine. I have to cancel out the front part. By the way, don't say sin. We're not at church. It's sine, cosine. Say the right words. So sine inverse sine is going to cancel. You're left with theta equals whatever. Type this into your calculator. And let's see what we get. 58.997. So I'm good to say this is 59 degrees. Please make sure it has the degree mark on there. Because it is an angle, it should have it. Alright, next page. Let's do it again. Part B. Based on this angle, you have an opposite, you have a hypotenuse. Which one of those are we using? SOHCAHTOA. So it is the SO part, sine of theta equals opposite over hypotenuse. Now you have to remember how to cancel a sine. Sine inverse. I also had somebody once try to cancel a sine with a tangent. Hopefully that makes sense to you why you don't cancel a sine with a tangent. We're going to use sine and sine inverse, cosine with cosine inverse. Okay, plug that into your calculator. And you get 61.04. The 4 is not enough to round the 0 up, so we'll leave it 61.4 or 0.0. Or you can just say 61. All right, try part E all on your own. You have 1 minute, and I will move on. Okay. So based on this angle, you have your opposite, you have your adjacent. So in this case, we're going to be using the tangent. Tangent theta equals opposite over adjacent. Now we have to get the theta by itself. So let's cancel the tangent using tangent inverse. The tangent and the tangent inverse cancel. You are left with theta equals, I forget that I need a calculator. I don't when I'm teaching because you all do it for me, but I'm alone. So theta equals 66.8. And last one. As we're doing this last one, go ahead and pass out the homework packet for this unit. And finish part F. And go ahead and start the homework. I'm assuming we're still before lunch on my A3 class. So from now until, if you're at this point and it's still before lunch, go ahead and pause the recording after we do problem F. And you can work on the first part of your homework until lunch. So the second part of the homework starts when it says special right triangles. This is new. We never taught special right triangles that year, or last year, so it's new, but it's going to help us in doing that unit circle from before, so it's kind of critical. All right, part F, really quick. This is our angle, this is adjacent, this is hypotenuse, so we're going to use the cosine of 53 equals 12 over x, make that into a proportion. So x times the cosine of 53 equals 12. And then divide by the cosine of 53. I don't need the degrees because it's not an angle. Really quick, I want to show you something we didn't see one. Sorry, there's the ugly stuff again. We didn't see one that looks like this. So if I have this right triangle, just watch, or you can write down, I really don't care. And pretend like this is 30. Pretend like this is x and this is 10. If I solved this triangle, we would again do everything that we have been doing. So angle, opposite, hypotenuse, sine of 30 equals opposite over hypotenuse. We haven't done one together where the variable is in the numerator rather than the denominator, and I just want to show you how to do that. It's pretty easy. However, it's so easy that sometimes people forget what to do. So when I cross multiply, I have x, 1x equals 10 times the sine of 30 And then usually I get asked, well, what do you do next? And I say, well, x is by itself, so just plug in 10 times sine 30. And you get 5. So you just plug it into your calculator. Okay, go ahead and pause that. If you don't pause it, it's going to feel like I'm not waiting. So pause it and come back after lunch. Have a good lunch. Unless you're watching this at home and then this is the recording my substitute gives. Whatever. Okay, we have 40 minutes left of class-ish. Now we're going to talk about special right triangles. There are two triangles that have similar properties. And let me show you what they are. The first is a 45, 45, 90 triangle. Because of 45, 45, 90, these two angles are the same, which means it better be an isosceles triangle. And this right here is kind of like the formula. You know how we have the quadratic formula or the slope formula? This is the formula, but it's on a triangle. So on a 45, 45, 90, these would both be 45. And we're going to call this n, because it's isosceles, and n square root 2. Now I can prove this to you using the Pythagorean theorem if you wanted me to. So right here, maybe make a big box. Please have that memorized. Okay, looking at the next one. How do I find the missing side using my special right triangles? Well, if this is 45, this is 45. And that means these are isosceles. So the very first thing that you would do is label this triangle using this formula. So the congruent sides are both n. And then the hypotenuse is n square root 2. So somewhere on this triangle, you have an equation with only one variable. Right here you have n and x, that's not going to help you. Right here you have n and y, that is not going to help you. But here you have a formula where I can get n by itself. So n is connected to the square root by a multiply. To get n alone, you would divide by the square root 2. And when you do that, those cancel, and so you have 3 over the square root 2. Now you don't like to have the square root in the denominator, so we need to rationalize the denominator. So, we come up here, n equals 3 square root 2 over 2. Now this is not my answer because my answers are x's and y's, but it helps get me my answer. I can use this n and make a substitute right here. So y equals 3 square root 2 over 2. And make a substitution right here. So x equals 3 square root 2 over 2. You could use trig to do this. However, trig will not give you an exact answer yet until you know those trig ratios from the unit circle. So this is special triangle will help us get those answers. Let's do the next one. So this is a square. Because it's a square, I've got right angles and I've got a bunch of isosceles sides. If this is 9.6, this is 9.6, this is 9.6. Now on this problem, the data given to us is a decimal, so I'm okay having a decimal as a final answer. Now really quick, because it's isosceles, I should know what x is right away. X has to be 45 degrees. Because I've got an isosceles triangle with a 90. Now, if I labeled these as n square root of 2, the isosceles sides would be n. So n square root 2. I know what n is, so I'm going to take this number and substitute it right here. And when I do, y equals 9.6 square root 2, which is 5 on my calculator. 13.57. 13.57. Okay, let's try another one of those. Part C. Part C. Really quick, I'm going to see if this is the last page in my notes. Yes, it is. Okay, again, you got this square with a bunch of isosceles sides. That means these angles have to be what? 45 degrees. So I've got an n square root 2, and somewhere on my triangle is an equation that will help me figure out what n is. So right here is my equation. 17 equals n square root 2, and to get n by itself I have to divide by the square root of 2. So you have to solve this equation. And we can't leave that so the square root is in the denominator, so let's rationalize. So n equals 17 square root 2 over 2. Now if n equals 17 square root 2 over 2, and x equals n, x would have to be 17 square root 2 over 2. So go ahead and pause this for just a second. And okay, with the person sitting next to you, behind you, around you, take like 5 minutes, depending on the time. I mean, check the time. Class gets over at 12:45, so if we don't have at least 20 more minutes left of class, don't pause it. But if we have a few more minutes, go ahead and pause it, and unpause it when we have about 20 minutes plus-ish left of class, or when you feel good to move on. Because now, okay, unpause. Excuse me. Now, we need to talk about the 30, 60, 90 triangle. This is the second formula, so you're going to have a bunch of writing on this page. Box this one. This is the second formula. Okay, so you got your 30, 60, 90. Across from the 30 is n. Across from the 90 is 2n. And across from the 60 is n square root 3. So we are going to be doing these problems just like we were doing the 45, 45, 90. We're going to do these ones just like we did the 40, 40, 45, 45, 90. So looking at this one, part D, I've got a 60, 90, so this missing one should be 30. Across from the 30 is n. Across from the 90 is 2n, comparing it to our formula triangle. And across from the 60 is n square root 3. So again, one of these three is an equation where you only have one variable. Which one is it? That one. Gosh, sorry. So, I have to solve this equation for n. N is connected by a multiply, so let's divide both sides by the square root 3. On the right, you're left with n. On the left, the square roots cancel actually, and n equals 5. So this is not our answer, but it helps us get our answer. If n equals 5, we can take this and substitute it right here. That means b equals 5. Take it and substitute it right here. That means a equals 2 times 5, which is 10. I love trig. I wish that I just taught trig. I love it. It's like a game. What did you do on your Saturday night? I went to Sweetheart and did trig in my classroom. I love it. Doesn't matter, it's fine. Oh, part E, there's no numbers. Okay, for part E, pretend like this said 5. Okay, so I've got a 30, 60, 90. Across from my 30 is N. Oh, we need more than that. Okay, sorry, typo. Pretend like this says 5. This says, I don't know, I guess A, and this says B. So this is my 30. Across from my 30 is N. Across from my 90 is 2N. And across from my 60 is N square root 3. So again, one of these has the equation where I can solve for N. In this case, it's the bottom one. So right here, we're going to solve that by dividing by the square root of 3. So N equals 5 divided by the square root of 3. Now we can't leave it like that because again you can't have a radical in the denominator. So let's rationalize the denominator. And N equals 5 square root 3 over 3. If N equals 5 square root 3 over 3, we're going to take this. We're going to substitute it right here. That means A equals 5 square root 3 over 3. And that means B equals twice that. So how would you double something like this? So if I times that by 2, I just have to combine those. So B would equal 10 square root 3 over 3. That's how that would double. Okay, part F, what kind of triangle do I have here? If you were to ignore this middle line, this is actually a isosceles triangle, and this is the altitude. So if this is the altitude, that means this is a 90. So we can completely disregard this part of the triangle. Now that we have a right triangle, I've got a 60, 90, that means this one has to be 30. And let's use our mad trig skills to solve this one. Across from the 30, you have N. Across from the 90, you have 2N. And across from the 60 is N square root 3. So one of these is the equation that will let us solve it. It is right here. Let's divide both sides by 2. To get rid of that 2, N equals 5.5. So if N equals 5.5, take it, substitute it here. X equals 5.5. And Y would equal, let's plug the 5.5 into here. So you make that substitution. 5.5 square root 3. Okay, go ahead and pause it. Talk to each other for like 2 minutes. Make sure you clarify any questions that you might have. Please make sure everybody is talking to somebody. Either be the helper or be the person being helped, but I need you to talk to each other to make sure you understand this. I'm not here, and I want to make sure you're good. Okay, part G is a little bit different. Part G, you have 2 different triangles being melded together. So this is your 30, 60, 90, because I have a 60, a 90, and a 30. And this is a 45, 45, 90, because I have a 90, 45, so the other one has to be 45. You would subtract it from 180 to get to 45. So I need to find X, but I can't find X because I don't know anything on this 45, 45, 90 triangle. However, if I could figure out this, decide that they both share, then I would know something about the X. So let's use the right triangle, find the hypotenuse, and then we will go over to the left right triangle to finish it up. So on the right, you've got across from the 30 equals N, across from the 90 equals 2N, and I don't really care about this side because it doesn't have to do with my hypotenuse, and I need the hypotenuse to carry forward. So one of those two is the equation, this one, and it tells us what n is, so I can take that, substitute it right there, and I can say that this length is 2 times n, which would be 12. Now you can disregard this triangle completely. I'll take that off, but you can disregard it completely and just look at the 45, 45, 90. On that triangle, across from the 45, the isosceles sides are n, and then the hypotenuse is n square root 2. So one of those three is an equation that will help you solve for n. Let's cancel out that square root 2. I can't leave it like that because I have to rationalize the denominator. So this is the same thing, n equals 12 square root 2 over 2. However, that can be simplified because I've got the 12 and the 2. So n equals 6 square root 2 over 1. Now that we know what n is, we can take it, substitute it right here. Final answer, x equals 6 square root 2. I love it. Okay, cool. Thanks for watching. Hopefully that made sense. Good luck on your homework assignment. Peace out.